Before we get started in this video, I wanted to share with you a joke on statistics that my wife shared with me earlier today. Well, on second thought, it's not really significant, so never mind. Hello, welcome to the Sigma Made Simple channel. This channel is dedicated to explaining the principles of Lean Sigma and Six Sigma to anyone with little or no knowledge but wish to make improvements to a measurable process. My name is Dennis Wells, and I was learning about these tools even before I was certified in 2008 as a Six Sigma Black Belt and a Lean Sigma Green Belt in 2009. I've acted as a Master Black Belt where I mentored many engineers for their certification, trained personnel, mentored interns, and trained managers on these tools. Even in semi-retirement, I continue teaching and learning as I believe in the power of these tools when applied properly. That is what I hope to show you on this channel. This video will describe the DMAIC process and how it works. So during this video, we're going to explain what is the DMAIC process, where it is used, how it applies to continuous improvement, and the roles of personnel involved in the DMAIC process. So what is the DMAIC process? Well, it's more like a toolbox or 5 phases that you use to keep your team focused and keep them focused on an improvement effort. These tools are define, measure, analyze, improve, and control. The first phase in every project is always define. This is where you outline the initial focus of the project. You accomplish this by creating the initial project charter. You will define the following parameters: the team for the project, the scope, the metric you wish to improve, a detailed and concise problem statement, the goals you wish to achieve, a business case for spending your organization's money and labor, and all counterbalances you want to ensure you do not impact negatively when achieving your goals. A link to the project charter video is in the description, along with an example project. A project charter clarifies the vision and keeps you on track. It prevents scope creep, and when questions come up later, or when you are confused about something, refer to your project charter's define phase to stay on track. Measure. Keep in mind this fact of Lean Sigma and Six Sigma. If you cannot measure it, you cannot improve it. The measure phase is where you answer the following questions. Where are we with the performance of this metric today? This will require you to jump to the control phase for a little bit. A previous project may have something in place from their control phase, but if not, you'll want to put some sort of control in place at this time to track current and proposed processes when they're implemented to ensure that you're getting an improvement. You're going to answer, how are we currently controlling the metric? Again, the control phase will help with this. You're going to ask, what risks and assumptions do we have about this metric or about our testing? Later videos will go into risk analysis and risk registers. But for now, all you need to know is the purpose of your risk analysis and your tracking your assumptions is so that you can avoid a type 1 or type 2 error. A type 1 error, quite simply, is where you think there's a change when there is no change. Type 2 error is where you think there is no change when there is. Dealing with risks and assumptions are key to avoiding these types of errors. When you go through the measure phase, you're also going to ask, do we need to update the project charter? Do we need to add team members? Do we need to increase or decrease the scope? Do we need to update the problem statement? Once you learn a little bit more, maybe the numbers in the problem statement weren't exact, so you're going to go back and you're going to update them again. You're going to ask yourself, am I looking at the right metric? Do I need to add a metric? Usually you're only going to focus on one metric, and then the other metrics will be your counterbalance to make sure you don't affect those. Sometimes you might have 2 metrics, but try to boil it down to one and ask yourself during the measure phase, do I have the right one? Do you have the right goals? Are they accurate? Once you get into measure, you might have to update those. You also might update your business case, and you might add, subtract, or change your counterbalances. You're also going to verify if any existing data that you did not personally collect is accurate, and ask, what was the same process used to collect this data? Is the process under control so we know that the data is consistent? We want to make sure that somebody named Bob wasn't doing it the last few weeks and he did it different than Jane did for the 3 months before that. You want to make sure that you've got consistent data. Also, did the measurement tool that you used for the measurements, does it pass gauge R&R? Most important thing is it good data? And when I say good data, I mean, is it usable data? We have another video coming up that's going to talk about looking at data to find out if it's normal data, to find out if you've got some other interactions going on, if you've got more than one factor affecting it. But that's for a later video. If you don't have good data, if you don't have usable data, the next best thing is to have no data. At least when you have no data, you know that you don't know anything, so you can develop something to start collecting the data. So we're going to go into more detail on those subjects a little bit later, but for now, you really want to understand about measure is after you get define, you jump in the measure, you might go back to define and update some of those things and make sure that you've got good data. So analyze. Analyze is where you look at possible solutions and then you test them. You can also analyze some of your measurement techniques, your equipment, things like that. You want to understand the impact if something you're thinking about changing is changed. This is another case where you're going to bounce between analyze, define, and measure until you have a really good idea on what tools you're going to use, what it is you really want to change, how you'll measure the change. Does it meet the criteria of a 95% confidence level? We'll go into that in a later detail in a later video. Just know that you need to have some kind of control or measurement technique. Whenever you compare data or use data in the Lean Sigma or Six Sigma, you're always looking for that 95% confidence level. You really want to understand what your impact is or what you expect to have for an impact. You should be able to predict the impact, and not perfectly, but you should be able to at least predict the direction and get pretty close to the severity. It may not be the actual or exact impact, but you should have a really good idea. You can do this through targeted testing of ideas and small scale impact studies. We'll have some examples later, but yeah, sometimes if it's a highly disruptive change, you don't want to jump right into it. If you're going to relay out the whole of production, you want to do some more testing. And if it's something simple like we're going to uh, change a small part of the process and see if it works, you might want to run that for a day on a production line just to see what happens. You want to ask yourself, are the counterbalances safe and are they being tracked? Quality can usually help with that, but you're welcome to put control charts in place for those as well. Yes, do we need to update the project charter, problem statement, the goals, business case, or counterbalance? So when you're in the analyze phase, you're going to be pulling in measure, you're going to be pulling in define, you're going to be putting them back until you've kind of got everything aligned. You're going to want to reflect on your test plan to ensure that you do not get lost in analysis paralysis. Eventually, you're going to have to make a decision. Don't spend an inordinate amount of time with testing. Just make sure that you feel reasonably confident with it. Just remember, a decision you can learn from today is better than a decision that's never made. Don't get stuck in analysis paralysis. Improve is where you make the change from the current to the proposed process. Personally, I think that this should really be implement and not improve, because no matter how much research you do, you may have overlooked something, especially in the beginning when you first start using these tools, until you understand all the ins and outs of your process and how those tools apply to it and how your process interacts with them. It is important to do the best you can, but accept that sometimes you're going to fail or you're going to have no impact at all, and failure is the best teacher. You may not always get the intended impact. This is especially true again when you're first using the tools. I think implement is also better because calling this phase improve, people think they've failed when they do not improve. That's not really the case. The processes have their own unique complexities, as I said before. If you have no impact or no unintended or an unintended impact, accept that. You may want to roll back to the current process until you find out why, or you might want to keep it in place and run back to um, measure, analyze until you figure out why you're not having the impact that you expect. Remember, you only fail when you stop the continuous improvement cycle. Lastly, control. It's probably the one phase that's the most overlooked from what I see other people doing projects, and um, projects should always include the control phase. A control that is always required after improve or implement is completed. However, it should already be in place either through a previously completed project or during the measure phase of the current project. Usually, you'll have this in place already, so it should be the easiest of phases. Many times, I see manufacturing drift back to their previous habits or back to the original or what I would call the current process, and then undo the improvements because there's no control in place. They just kind of over a weekend or whatever, they forget what they did and then they kind of revert back. Especially if you've made a change on a Friday before a 3-day weekend, they're probably going to come back and just go back to what they were doing before. Control is what keeps everything in place. So also, it's also going to verify your impact, maintain the impact. At this point, when you get into the control phase, you might want to update the project charter, kind of wrap it up for this project, update the problem statement, the goals, the business case for what really has occurred, and then the safety of the counterbalances. One of the other important aspects of control phase is you can use it for collecting data for Pareto charts that will show you where opportunities exist for future projects. Also, control can be used to look at a metric drift over time to predict when a metric will be unacceptable. So for instance, if you've got a plastic or if you've got a mold making a plastic part, you got a convex surface on there. As the mold wears, it's going to get bigger. And if it's a critical dimension, you can measure it over time and then you'll see a drift. And then you can say, it's going to be out of spec in about 6 months. So let's schedule some downtime in 5 months to rework this. Things like that. So control phase is very important. So where's the DMAIC process used? The DMAIC process is used in both Lean Sigma and Six Sigma, but it's not limited to these tools. If you apply the ideas to other projects, you can benefit just about anything you can benefit from the DMAIC process. Sometimes you have what seems like a simple project, go through the DMAIC process. You may not use all the tools for Six Sigma or Lean Sigma, but it can help you keep focused. So how does the DMAIC process apply to continuous improvement? Well, the DMAIC process is actually not linear. Some people think of it like a wheel. You go define, measure, analyze, improve, control, and you just keep going around and around. And you do keep moving, but really what happens is you start with define, go to measure, you pull and define, you put define back, you go to analyze, you pull and measure and define, put them back. You go to improve, maybe you pull in, define, measure, analyze. And all along the way, you're pulling in the control phase and putting it back. You're using these like tools. Remember, the control is not the end of the project. Control is a way of ensuring that you have the intended impact and that your improvements continue and gathering data for Pareto chart for future opportunities and when a statistically significant event occurs. These are the roles of the team in the DMAIC process. Participants are people who are personnel who are completing the processes which are targeted for improvement. Greenbelts do the measuring of the areas that need improvement. They work with the participants to ensure the participants' needs are being met. They execute the test plans and ensure the data is usable. Black belts are the project leaders. They write the project charter as well as mentor the green belts to become black belts. They have a good understanding of the DMAIC process and the tools used to support Six Sigma or Lean Sigma. They write test plans with input from the green belts and participants and master black belts. The master black belts are the people who decide what projects to work on, who's going to work on them. They provide training on tools used to support the black belts and management. Advanced knowledge on tools supporting Lean Sigma and Six Sigma is required for a master black belt. They mentor the black belts. Their role is to ensure that projects are moving along, the right tools are being used, and the tools are being used properly. They are the person that the black belt comes to if a situation does not quite fit a tool or doesn't quite feel right. They should be able to offer ideas on why results are not being achieved and how to modify a tool for that particular need. A stakeholder is the person who's most impacted by the change in the process. If it is an external customer, it may be a salesperson. If it is a manufacturing area, it would most likely be the manager of that area. If the improvement affects more than one area, there may be many stakeholders or one person who all the stakeholders report to. That would probably also be the next person, which is the champion. So the person all the team members eventually report to is your champion. If it's a project where only one area is impacted, the area manager may be the stakeholder and the champion. If the team is made up of 5 areas, then find the one manager or leader that all groups share as you go up the chain. That person should be the champion. The champion's role is to balance the needs of the company as they relate to the areas impacted and decide on priority. They are the people who have the authority to ensure participation in all the areas the team represents to make things happen. They also keep this project aligned with the organizational goals, culture, and mission statement. So, the next video will be the first in a series explaining what Lean Sigma is and eventually Six Sigma, and then we'll get into some projects and some tools. If you found this video useful, like it, subscribe to the channel, and share it with anyone else who may find it useful. If you didn't find this video useful, then subscribe in the hope that an upcoming video will be. Eventually, we'll go through projects using the Lean Sigma and Six Sigma tools, as well as the tools needed to support them. Remember, a wise person learns from their mistakes, while a genius learns from the mistakes of others. Be a genius, and we'll see you soon.